Well, hi, hello, and welcome to Lesson 15. Lesson 14 was an exam. Lesson 15, we march on toward Exam 2. This lesson is all about implicit differentiation. What the heck is that? Well, that's a good question. Some functions come at you and they look kind of bizarre. And you're like, what do I do with this? Like, I can take the derivative of this thing over here, that's not bad, and I can take the derivative of this guy over here, that's not bad. And then this is sort of a product rule, right? This is a product rule thing. So like, what do we do with that? But if I wanted to, I could solve for y. I could get that y is x squared plus 2 over 5x, and I could take the derivative of this thing explicitly. Implicit differentiation is what we do when the function, when the equation whose derivative we are looking for, well, we can't get y by itself. We just can't. We cannot get y by itself. Like, we could take the derivative of this side, that's not bad, and we could take the derivative of this even. The derivative of this is a product rule, so the derivative of this is first times derivative second plus second times derivative first. That's an interesting question. What's the derivative of y cubed? Well, you would think that the derivative of y cubed is 3y squared, and you'd be almost right. Because when we take derivatives with respect to x. So the derivative with respect to y is 3y squared. But to get to the derivative with respect to x, the chain rule says we have to multiply by dy dx. Because the chain rule says that the derivative of this function with respect to x is the derivative of this function with respect to y times dy dx. And then the algebra on that works out the way we want it to. Similarly over here, the derivative of the sine of something is the cosine of something. Like, that's wonderful. But the derivative of this function with respect to x is the derivative of this function with respect to this angle times the derivative of the angle, and that's a product rule problem. First times derivative second, the derivative of y is exactly what you think it is, plus second times derivative first. This is a situation where the differentiation is implicit because it is not possible for us to isolate y. So if it's not possible to isolate y, we do we do this process called implicit differentiation, and here's the basic idea. We differentiate both sides of the equation with respect to x. We use the chain rule where we need to. We use the product rule where we need to. We use the quotient rule where we need to. We take the derivatives on both sides with respect to x. We collect all the things with dy dx to one side. All the terms with dy dx go to one side. And then we factor out that dy dx and we divide. So this is the thing that goes in your notebook or wherever it is that you're keeping track of notes. This is the process you want to have in your notes. I will do a couple of examples that should help to illustrate that point. So we're going to find dy dx if x squared plus y squared is 1. This is the familiar circle. It's the unit circle. It is not a function. We cannot get y by itself. This is not a function. We are looking to take derivatives of something that is not a function. So step 1 says that we take the derivatives of both sides with respect to x. Well, the derivative of the right side with respect to x is easy. The derivative on the left side, well, the derivative of x squared is pretty straightforward. And the derivative of y squared, well, that's 2y if the derivative we're looking for is with respect to y, but it isn't. We're looking to take a derivative with respect to x. So the derivative of this function with respect to x is the derivative of this function with respect to y times dy dx. So then step 2 says we get all the dy dx stuff to one side and all the non-dy dx stuff to the other side. And this is algebra, pure and simple. Well, step 3 says we factor out a dy dx, and that's already done. There's no other terms here with dy dx. So step 4 says we divide to finish off the matter. Dy dx, we get it by itself. That's a plus 2y, and the 2's cancel, and we get negative x over y. What does that mean? That means if we want to know what the derivative is at this point, the derivative at this point is negative x over y. If we want to know what the derivative is at this point, it's negative x over y. We can find the slopes of tangent lines all the way around the circle in this way. It is impossible for us to get y by itself here, so it is not ridiculous to imagine that the derivative will involve y. I will illustrate with one other example in this video. We're going to find dy dx if 2xy plus 5 squared equals 3y. So step 1 says we're supposed to take the derivatives on both sides with respect to x. So the derivative on the right side is pretty straightforward. The derivative of y is dy dx. So we're pretty straightforward on the right side. On the left side, well, that's a matter entirely different. This is something squared, so the derivative of something squared is 2 times that something to the first power times the derivative of the inside. That's chain rule. Well, what's the derivative on the inside? Well, that's a product. So we're going to find that derivative using the product rule. And the derivative of product, well, that's first times derivative second plus second times derivative first. So now what? Well, now we do a little bit of algebra, because step 2 says we pull all the dy dx stuff to one side and all the non-dy dx stuff to the other side. Well, the dy dx stuff is what we get when we distribute that and also this thing over here. So the left side is 8x squared y plus 20x dy dx minus that 3 dy dx. The other side is what happens when we distribute this to there and kick it over to the other side. That's negative 8xy squared minus 20y. So step 3 says we're supposed to factor out a dy dx, and if we do, then what's left on this left side is an 8x squared y plus a 20x minus 3. The right side remains unchanged. And then step 4, we divide. So dy dx is negative 8xy squared minus 20y over 8x squared y plus 20x minus 3. I will record a second video with extra examples in it. You are free to watch it if you like. If you're just looking for practice to see how you are, you're looking in section 3.8 of Strang's textbook. You're looking at 301 and 303 and 307 and 317 and 323. Okay, so second video coming up for those who think they need it or who want the extra practice.